So, hello everyone. Today we are going to start our new lecture, that is lecture number 9, that is regression modeling. And in previous lecture we will see the clusterings, and today we will discuss or demonstrate about the estimation model evaluation using Python and demonstrate the stepwise regression using Python of the regression modeling. So let we move to our PPT, and here the regression modeling exploring the power of prediction. So here we will discuss the regression modeling is all about uncovering the relationship between the variables and using those relationships to make predictions. For example, predicting house prices based on size, location, and antimities. But it's not about the prediction. Regression help us to understand the why behind the data. So in this video lecture, we will cover how to evaluate the regression model using Python, visualizing performance to uncover the strength and weakness, and the role of the stepwise regression in refining the models. But at the end, you will have the actionable knowledge of applying regression modeling in your own projects. So now evaluating the moving forward for to the estimation model evaluating using Python. So it generally includes four. First one is that evaluating performance. Second one is visualizing result, and third one is addressing bias, and the last one is stepwise regression using Python. So let's discuss one by one. So first is evaluating regression in model. Let us start by evaluating the regression model. After training a model, it's a critical to use how well it perform, and Python provides some handy metrics for this. So first it provides the R squared. This tells us how much of you the variance in the target variable is explained by the data. Second one is RMSE, that is root mean squared error. This shows the average error in prediction and giving you us as a sense of how far off your predictions are. And and the third one is MAE, mean absolute error, a simpler metric that calculates the average of absolute difference between the predict and the actual values. So now moving towards the visualizing model performance, that is the second part. And first, the once we have calculated the metrics, the next step is to visualize the result. Python libraries like Matplotlib and Seaborn make this easy. And a residual plot shows the difference between the actual and the predict values. And ideally, these residuals should be randomly distributed. Any pattern could be indicate issue with the model. So, and now the third one is the addressing bias. The bias is a model occur when it oversimplifies the data, and this can lead to inaccurate predictions. To techniques like feature engineering and regulation are the key to minimize bias. And now let's talk about the stepwise regulations. So in stepwise regulations, we have basically three points. That is, one is feature selection, second one is model refinement, and third one is avoiding overfitting. So now we will discuss about the stepwise. And by refining the model this way, we reduce the overfitting and improvement generalization to the new idea. So first, the feature selection. This approach involves the systematic adding or removing variable from the model based on statistical significance and goodness of fit criteria. Second one is model refinement. A stepwise regression help us to build a Parsimonious model, reducing the number of variables while retraining predictive power and improving the model stability. The third one is avoidance overfitting. It is by strategically selecting the variables and stepwise regressions helps in preventing overfitting, ensuring the model generalization and unseen data. Now, these are the takeaways of our topic, that is regression modeling, and here are the key takeaways. And so basically, to wrap up here, we are all the key takeaways. And the regression modeling help us predict and understand trend in data. Evaluating metrics like RGARD, RMAC, MAE are essential for accessing performance. And visualizing result helps identifying the strength and weakness in the model. And the stepwise regression built a simpler, more interpretable model while avoiding overfitting. So, this is all from my side, and thank you for joining today. And don't forget to like, subscribe, and share. Thank you.